Hi everyone, good to have you here. This is E+ Academic Resource Center where we take online tutorials for undergraduates and senior secondary students. My name is Chinedu. Welcome, okay? All right, first of all, I want to thank you for the likes, thank you for the shares, thank you for commenting, thank you for inviting people to be part of what we're doing. Thank you for subscribing. You motivate and inspire us to do more, okay? If you know that you have not subscribed and you know we are giving value, you are getting value from what we're doing, please invite people, share the link so that people can be part of what we're doing, okay? All right, today we're going to be looking at Poisson distribution. We have done some introduction in our TikTok, on our TikTok handle, Instagram handle, and our Facebook handle, okay? I'm going to drop the link to our handles on the description section so that you can, you know, see what we have for you there. Okay, quickly, let's go to what we have for today. So Poisson distribution, we have looked at the binomial distribution before now. So the Poisson distribution. So now when we say Poisson distribution, what do we mean? Poisson distribution is a discrete probability, okay, that help us explain the number of time an event is likely to occur within a given time interval. Okay, it helps us know or explain how a number of events is likely to happen within a given time interval. For instance, if we say we want to know how many, lest I forget, now know this, the Poisson distribution is applicable to real life issues or real life experiments. Okay, you want to know the number of people visiting a filling station, a number of cars coming to a filling station at a particular time interval. You want to know how many patients visit a clinic at a particular time interval and all that, okay? So explaining our definition now, let's say we want to know how many customers visit a restaurant at a particular time interval, okay? Poisson distribution will help us ascertain that. Is that okay? Now, there are properties of Poisson distribution. We have about 6 of them, but let me just give you 4 of them, okay? Now, number 1 says here, I'm going to post them on the screen so that you see them. And also we have like 2 questions we're going to solve using the Poisson distribution. I'm going to post them on the screen too so that you will see them, okay? Now, one of them says the events are independent of location, time, region, or space. Now, what we are trying to see here is that the occurrence of one event does not in any way affect the occurrence of another event. That is to say, if you want to know how an event occur within a given time interval, it does not, the events are independent. No one is dependent on each other. Okay? If you want to know how an event occurred in one time or space, is dependent on whether another one happened in another time or space. I don't know if you get it. No one is affecting each other. Yeah, the result of this one does not affect the result of this one, or the outcome of this one does not affect the outcome of this one. Okay? Now, number 2, you say it has only one parameter, which is the lambda. It's called the lambda. Okay? One parameter is called the lambda. It's also known as the mean, which is also the variance. Okay? It's called lambda. Lambda is a symbol called lambda. Okay, it has just one symbol. It's known as the mean and it's also the variance. Okay, now number 3, the sample size is infinite. What they're trying to say here is s is equal to 2, 1 can be equal to 1, 2, 3 is infinite. Unlike the binomial distribution where the sample space is finite. Okay. The sample space is finite, but in Poisson distribution, it is infinite. So, to help us ascertain our results using the Poisson distribution, if you remember in our previous video when we were treating binomial distribution, I gave us some concepts that will help us. I gave us some concepts. Let me refresh our memory. I gave us some concepts. I said, when p is equal to x greater than or equal to, okay, z, for instance, okay, this can also be rewritten as this: 1 minus p, open brackets, okay, open brackets, x less than z, okay, open brackets, less than z. This one, the same thing as this. Okay? So when you have higher computation, in binomial distribution, I told you, when you have higher computation, you choose the concept that will help you ascertain with the lower computation. For instance, if we have 1, 2, 3, 4, 5, 6 sample space, for instance, and I said at least 3, at least 3 means 0, 1, and 2. At least 3. Okay? 0, 1. Sorry, at most 3. At most is 0, 1, 2, and 3. At most 3. Okay? That's what it means. At most 3. So if x is less than 3, it means that 3 is not included. So we have x, so we have 0, 1, and 2. Okay? So we compute for 0, 1, and 2 if x is less than 3. But if x is less than or equal to 3, we have 0, 1, 2, and 3 because of the equal sign. Okay? So if we are solving for x is less than 3, we have 0, 1, 2 to compute for. So between 0, 1, 2, and 3, then 3, 4, 5, 6. Which one is easier? Which one has a fewer computation? This one has a fewer computation. Okay? So we have 0, if s is less than 3 now, I'm talking about. So we have 0, 1, 2, 0, 1, 2 to compute for. I don't know if you understand it. Okay. So let's say, okay, we will solve with a sample. There are 2 samples here we'll solve with. Okay? You understand it better. Now, unlimited, number 4 of the properties, we have unlimited number of possible outcomes. Yes, the outcome is unlimited, unlike the binomial distribution. Okay, let's quickly solve a question. But before we solve a question, let's look at the formula for the Poisson distribution. We have P is equal to X, okay, let's P brackets X minus S equal to Z, equal to, let me change this. Okay, so we have the formula as P equal to X, is equal to Euler's function raised to the power of minus lambda, okay? Then lambda raised to the power of Z all over Z factorial, okay? Are you with me? Okay, now, so this one here, this symbol here stands for Euler's, it's called the Euler's function or number. Okay, this one you already know is the lambda. This one is the factorial function. Okay, so now the lambda here is the mean. Okay, the mean, the average number of an event occurring. That's the lambda. Then this Euler function is a constant, just like we have the pi. Okay, pi 22/7 is a constant function. Okay, while the z is the number of events occurring. Okay, the number of events occurring. While the lambda is the average number of events occurring. Yeah, this is the probability of what an event occurring. Okay, all right. Having done that, let's go straight to a question. Let's solve the question to help us understand it better. Okay. Now we have here question 1. The average number of customers that arrives a restaurant per minute is 2. The average number of customers that arrives a restaurant per minute is 2. Find the probability of arrival of 5 customers in 1 minute. Now, the average number of customers that arrive, our lambda here is what? Per minute is 2. Our lambda is 2. Okay? Then find the probability of arrival of 5 customers. Okay, so our z here is what? 5. Okay? So how do we solve now? We use our what? Formula. So we have x equal to 2. Okay? Which is equal to Euler's function is given as 2.178 approximately, okay? Yeah, if I'm not mistaken, let me see. The Euler's function is 2.718, sorry. 718, that's the Euler's function. Okay, it's approximately 2.718. So we have e raised to the power of lambda, then lambda raised to the power of z all over z factorial, okay? That's the formula. So let's compute now. So we have p all over x equal to 2, right? Which is equal to 2.718 raised to the power of our average number is 2 raised to the power of 2. This is 5, sorry. Okay? Then lambda is 2 raised to the power of 5 all over z, 5 factorial. We have 5 times 4 times 3 times 2 times 1. Okay? So p s equal to 5 is equal to 2.718 raised to the power of minus 2. Okay, so let me use the calculator now. So 2.718 raised to the power of minus 2 will give us 0.135. Okay, 35. Okay, then times 2 raised to the power of 5 will give us 2 raised to the power of 5 is what? 32. Okay, all over 5 times 4, 20. 20 times 3, that is 60. 60 times 2, that is 120. Okay, which is equal to 0.135. This is approximately, okay? 0.135 times 32, which is equal to what? 4.32 all over 120 divided by 120. 4.32 divided by 120, which is equal to 0.036. Okay? So these are answer. I hope you understand how we impute our figures. Okay? All right. So let's move over to the next question. I think that one you will understand it properly. Okay. Welcome back. All right. So the second question says, a business outfit receives an average of 4 calls per hour. Okay? Calculate the probability that A, 6 calls are received in 1 hour. B, at most 2 calls are received in 2 hours. C, 2 calls are received in 2 hours. D, at least 2 calls are received in 1 hour. Okay? Okay, let's go back. Let's solve. Solution. Now, a business outfit received an average of 4 calls. Our lambda is equal to 4. Okay? That's our lambda. Equal to 4. Calculate the probability that A, 6 calls are received in 1 hour. So for A, we have P bracket S equal to 6. Okay? So 6 calls are received. So we have Euler's function raised to the power of lambda is what? Lambda is, let me go straight to imputation. 2 points, what is our lambda again? 718. Raised to the power of minus 4. Our lambda is 4, okay? Times 4 raised to the power of 6 all over 6 factorial, which is same thing as 6 times 5 times 4 times 3 times 2 times 1, okay? Which is equal to 2 raised to the power 2.718 raised to the power of minus 4. Let me use our calculator. 2.718 raised to the power of minus 4 will give us 0.0183, okay, times 4 raised to the power of 6. 4 raised to the power of 6 will give us 4,096, okay? Let's see, 4 times 4 times 4, 4, 4, 4, okay? All over 6 factorial is 6 times 5, 30, 30 times 4 will give us 120. 120 times 3 will give us 360. 360 times 2 will give us 720, right? Times 2, 720, okay? Which is equal to, okay, 0.0183 times 4096, okay, equal to 74.9568 all over, okay, divide by 720, which is equal to 0.1410, sorry, 1041. Okay, this is the answer to the A question. Are you with me? Please use the comment section. Anywhere you don't understand, we'll solve together. Let's move over to the next question. The next question says, at most 2 calls are received in 2 hours. Okay, now if you observe something here, at most 2 calls are received in 2 hours. From the question here, our time range here has been 1 hour. But here now, they're talking about 2 hours. So that means our mean will be multiplied by 2. Hello? Remember, one of the properties of the Poisson distribution is that the mean is constant for all intervals. The mean is constant for all intervals. So if 4 is our mean for 1 hour, then for 2 hours, our lambda will be what? 8. That is 4 times 2 hours. Our lambda will be 8. Are you with me? Hello, are you with me? Please use the comment section if you don't understand. One of the properties of the Poisson distribution is that the mean is constant for all intervals, okay? So if for 1 hour, our average call is 4, then for 2 hours, the average call will be 8. That's 4 times 2, okay? Okay, let's go. Now, at most, 2 calls are received in 2 hours. So at most will be 0, 1, and 2. Okay, at most 0, 1, and 2. 0, 1, and 2. At most. When you say at least, it means from 2 upwards. So when you say at most, it's from 2 downward. This is what I was trying to explain previously. Okay, at most, if I say at most 5, what do I mean? I mean 0, 1, 2, 3, 4, 5. If I say at least 5, it's 5, 6, 7, 8 till infinity. Do you understand? Okay, now, so our question here says at most 2 calls. That is to say, P bracket X S less than and equal to 2. Okay? Because 2 is included. At most, okay? At most 2 calls. 2 is included. So, which means 2, 1, and 0. S is less than or equal to what? 2. So we have P brackets X equal to 0 plus, okay, let me use a wider space. This is to tell us that P equal to 0 plus P X equal to 1 plus P S equal to 2. So we are going to solve for 3 of them. Okay, so what you will do is, this is how you solve it. You solve for 0, you solve for 1, you solve for 2. Then add your results. Let me do 1 for you. You do the second one and the third one, then add whatever you get. P S raised to power 0 is given as Euler's function is 2.718. We are using our formula now. You use your formula for each of them, okay? 2.718 raised to the power of minus 8. Remember, I told you, since we are solving for 2 hours, our lambda, which is our mean, will now be 8, okay? 8 raised to the power of 0 all over 0 factorial, okay? Hello, are you with me? Please use the comment section if you don't understand. So we have 2.718 raised to the power of 8, okay? Whatever you have, let me do this. 2.718 raised to the power of 8, okay? Raised to the power of minus 8, sorry, minus 8. It will give us 0.0001 3. Okay? Times 8 raised to the power of 0 is 1. 0 factorial is 1. Okay? Hello, are you with me? So you multiply your answer, whatever you get, multiply your answer divided by 1, whatever you get, use the same approach in solving for s minus 1. Use the same approach for s equal to 2, sorry, and s equal to 1. Whatever your results are, add it together. Then second method you can use in doing this is this. You just say the mean is minus 8, right? So let's say we have, I'm giving you second option now. The first option is this. Use this method, solve for each of them. Solve for 0, solve for 1, solve for 2. Using the way we have done it here. Then your answers, add them together. When you add your answers together, because we have a positive sign here. When you add your answers together, whatever it gives you is the result. Then alternatively, what you will do is Euler's function, okay, times lambda raised to the power of z all over z. Okay, now for this one we have the Euler's function. The mean here is minus 8, right? Okay, then we'll have what is it called? The mean is 8. Okay, 8 raised to the power of 0 is 1. Okay, 0 factorial is 1. 8 raised to the power of 0 is 1. 0 factorial is 1. 1 plus. Then for minus 1, for equal to 1, sorry, 1 raised to the power of 8 raised to the power of 1 is 8. Okay, 1 factorial is 1. Okay, then plus 2. Now 8 raised to the power of 2 is 64. Okay, 2 factorial will give us 2. 64 divided by 2. Are you with me? Are you following? Okay, so for the third one will be the lambda here is 8. 8 raised to the power of 2 is 64. Okay, 2 factorial will give us 2. So 64 divided by 2, whatever you get, this will give us 32. Okay, so e raised to the power of 8, you add all this together. When you add all this together, let's say what we have here, let's say for instance, this is 20. Okay, so you do your Euler's function, 2.718 raised to the power of minus 8 times this. Whatever you get is your answer. This is another way of doing it. Okay, all right, I don't want the video to be too long. We are left with two answers, two questions here. That is the C and the D. 2 calls are received in 2 hours. At least 2 calls are received in 1 hour. I need you to solve it. Let me know you understand it. Solve these two, okay? You can take a screenshot and paste on our Facebook wall, the comment section. Go to our Facebook page, paste it on the comment section. I will go through it and assess you. Please, if there's any part you don't understand, call my attention. Use the comment section. Let me know where you don't understand. Thank you for staying to the end of the class. See you next time.